Hello, everyone, and welcome to today's deep dive webinar about black soldier fly larvae composting. Good morning, good afternoon, good evening, wherever you are. We're happy you're joining us today. Before we start, there are some housekeeping rules, as always, that I would like to give you on the way. The first is, if you have any questions, don't hesitate to post them. Please use the questions box for that. We will give you a lot of time in the end for your questions to the panelists, but it's always good to just remind to post them right away. So if you look on the right side in your control panel, there is something called questions. Just post your questions there, and also indicate to whom your question is directed, to which one of our two panelists. And if you have any general remarks, want to say hello, want to share any information, please use the chat box for that one. This webinar will be recorded, and we will also share the slides of our panelists. Thank you already for both of them for agreeing to that. And you will be able to find the recordings and the slides in a couple of days on the NUA campus website, where you also registered for this event. Today's webinar is brought to you by the Wuppertal Institute for Environment, Climate, Energy, and UN Habitat under the Urban Pathways Project, which is financed by the German Federal Ministry for the Environment under the International Climate Initiative. In the project, we cooperate with cities in the Global South to implement activities in the areas of sustainable mobility, energy, and waste management. The aim of the project is to contribute to the climate targets, the SDGs, and the new urban agenda. We also organize compatibility exchange of good practices, because we believe that we can all learn a lot from each other. That is also why we are organizing this series of deep dive webinars, following our first webinar series or one of our other webinar series on organic waste management, which we did early last year. If you haven't seen that one, you can also find it on the NUA campus. It gives you an overview in different languages about organic waste treatment case studies around the world. Today's topic is, again, treatment of organic waste, but we will look closely at black soldier fly larvae composting. This is another interesting possibility to treat this largest municipal solid waste fraction, after we talked last time about anaerobic digestion. We will hear first some fundamentals and then experiences from a Kenyan practitioner. But before we get started, we want to hear from you. So we have prepared two polls for you, and we are going to launch the first poll to find out which sector you are from. And please select one. If you are either a national or regional government, from a municipality, from an NGO, from a private sector, or from an academia, whatever you feel more comfortable with. And this is just to see how responsive you are, if you wake up, if you're ready to get engaged in this webinar with us. I'll give you a few more seconds to decide if you want to vote or not. And before we close that poll, and we will close the poll. And here you can see the results. So actually about half of you are from NGOs. And every time we do these webinars, it's a different mixture. So it's always very interesting. So today, a lot of people from the NGO, from the private sector, academia, not so many from the government side. Great. And then we will go to our next poll, the second one, just to know where your knowledge level is. So we want to know if you've heard of black soldier fly larvae composting before this webinar. So before you read about it however you were made aware of this webinar, either in our newsletter or on the mailing list or social media or someone who told you. So the answers you can give is yes, no, or the last one is we even already have it in our city. And I'm giving you again a few seconds to vote. Oh, there's a lot happening right now, depending on who's voting. Okay, let's close the poll and show you the results. There we go. Actually, well, half maybe. 43% say yes, they've heard it. 43% no, and 14% say we already have it in our city. Great. So I think that's a good basic for our discussion later on, for our Q&A, where maybe we can also engage a bit with you as the audience. And great. So I think we can get started with the first presentation. And I'm very happy to introduce to you Moritz Gold, who holds an MSc in environmental engineering and just completed his doctoral research on developing the black soldier fly biowaste treatment technology for the production of more sustainable animal feeds. He is passionate about resource recovery-based liquid and solid waste management. Moritz is a postdoctoral researcher at ETH Zurich, as well as an independent advisor, and supports the implementation of urban biowaste management based on circular economy principles. He has worked on decentralized wastewater treatment in India with GIZ and eawag on fecal sludge management in Eastern and West Africa. And we can see you, that's already good. We can see your screen, and we can also, I think, hear you. So I would say, there you go. Please, the floor is yours, Moritz.
Thank you, Nelly, for the introduction. Can you hear me? Is that confirmed?
Yes, confirmed.
Perfect. Thank you. Thanks for the introduction. Thanks for the invitation. Hello, everyone. Welcome to my presentation. I'm going to give a rough or a very short overview over black soldier fly larvae biowaste processing or composting or treatment, how it's also called. Thank you for the invitation. And it seems like I don't need to give a big introduction into the global waste management challenge. So you're all aware that large amounts of waste are being produced, and this generation is increasing in the coming decades. And actually, a lot of this waste problem is organic. So depending on the income category, more than 50–60% of organic waste is organic. And one challenge that I see with managing organic waste is the low value of the end product in comparison to iron or to paper or to glass or to plastic, where the raw material has a fairly high end product value. If we look at compost, which is a common treatment product for organic waste or bio waste, it's usually, let's say, 10 cents, 20 cents at most per kilogram. And one reason why we're considering black soldier fly bio-waste conversion is because the treatment end product has a much higher treatment value. So the treatment end product here is shown on the left are black soldier fly larvae, so the larval biomass. And this biomass, either fed live or also processed into feeds, has a market in agriculture, pet food, and different livestock, especially for poultry and pigs. And the value of these end products is much higher. So they can exceed $2–3 kilogram at $1 per kilogram of feed end product. And so the revenue that can be created from the treatment end product, from the raw material, is much higher in comparison to the traditional treatment technologies such as composting or anaerobic digestion. Another reason, looking at it not from a waste management perspective, but from a feed or food perspective, there's a big global need to find more sustainable animal feed sources. So you might know that fish meal production, soybean production, which are some of the traditional feed sources, are associated with environmental problems, so deforestation and overfishing. There's a lot of competition also between soy and human food production, since those areas can't be used for something else. And in general, especially also in low-income countries, there is an access problem to quality animal feed. And even though we're globally turning to eating less animal-based foods, animal-based foods are important for diets and also important for livelihoods. So there is a strong need for alternative animal feed sources, and that's where black soldier fly larvae can play a role. So now taking a step back, what are these black soldier fly larvae? So you can see here the life cycle. A lot of you probably have seen the black soldier fly larvae or other fly larvae. So in Europe, it's commonly the house fly or the fruit fly that you find in the summer in your compost. In warmer climates, you have them all year round. It's those little tiny larvae that you find, and during their life cycle, they feed on a variety of different organic waste and grow, and then turn into pupa. And from these pupa, the adult flies hatch, and then they try to find a partner. They mate. the female flies lay eggs, and you have young larvae offspring that are then looking for an organic waste feed source. And this life cycle, how long it takes, here some tentative timings are mentioned, but it depends sort of on environment, temperature, light, organic waste source. So the life cycle takes much longer on a low nutrient feed and on a cold climate than it does in a tropical warm climate. And so what has happened in the last, I would say, 10, 15 years, and especially in the last years, is that this natural life cycle has been engineered into these black soldier fly treatment or composting facilities. And as you can see here, they include waste sourcing, waste pre-processing, which might include dewatering, shredding of the waste, removal of plastics, of glass. And then there is the waste treatment, where the larvae consume the biowaste and convert it into body mass. There's product harvesting, where the larvae are separated from the processed residue, which is sort of like a compost material. And then there's refinement of the residue frass compost product and refining of the larvae. And as you can see here on the top, rearing. So obviously this process relies on young larval offspring to treat more organic waste. So separately to this waste treatment, there's always a colony where you rear flies that mate, produce eggs, and out of these eggs you have offspring hatching. And here just an overview, and this is a really incomplete list because a few years ago, I think it was still possible to sort of map all companies that are existing worldwide or all initiatives. I would think boldly now, I think you have startups or companies in every country in the world working on black soldier fly treatment and composting. These are some of the big companies, but you can also reach out to me if you need more information. But I think also on the internet, you find now startups all over the world, North America, South America, Europe, Asia, Australia, and also a lot in Africa. So now I just want to quickly walk you a bit more detail through these different steps that I've mentioned. Here on the left side, you see a fly cage. We call it a love cage because that's where the love between female and male flies is happening. So here the goal is to have efficient mating of female and male flies before laying of the eggs by the female flies. And in general, for the process, it's important to have sufficient quality and quantity of light. So the flies only find each other if the correct light is available, and this is typically under natural light. So if you have a small system, you can have it outside and the light is provided natural, or you have artificial light, and there you especially need blue or green light sources. Also important that the black soldier fly is a tropical fly. So it typically works temperatures exceeding 20, 25 degrees. So that's why it's especially a promising technology for tropical regions, warm regions, where you don't have to heat year round. So in North America and Europe, obviously in the winter, there's a lot of energy going into heating the entire facility because the larvae and the flies only traditionally live in warm climates. And this picture here shows the fly during oviposition, which is when it lays the eggs. So it lays these eggs in sort of cracks. These are just plastic balls here, but it could also be cardboard or wood. And out of these small eggs, the larvae offspring hatch that are then used in waste treatment. Before you place the larval offspring on the biowaste, similar to any other biowaste treatment technology, you need to sort of know how much waste are you treating per larvae. So there's a fixed feeding rate, so therefore you need to count the larvae and dose them so you can have an efficient and a reliable process. And this can also be optimized. Also, you can have an automatic counter that counts it, for example, based on light detection. And here it's in smaller facilities, this is typically done manually. Then coming to the heart of the facility, which is taking the larval offspring and placing them in these crates. So waste treatment often is done in these crates, which are placed on pallets. But in bigger facilities, this could also be optimized, basically a robot stacking, unstacking these crates, or it can also be a bed system or a bin system with larger bins, or even concrete sort of slabs on the ground. So there's a lot of variability in what people use. This is really depending on the scale, so the size of the facility, what is convenient, what are labor costs, and what technologies are existing in these environments. One key consideration for such facilities is what biowaste you're using and what biowaste basically the insect likes. So the black soldier fly is an animal like other farmed animals that we rear, such also as humans. So they're a bit selective in terms of the substrate they prefer for optimal growth. I don't think there's many substrates, many ways that the larvae don't like or they will die off, but the performance goes down on certain substrates. So for example, when you see here on the left side, you see different substrates. You see, for example, cow manure, and you have on the x-axis waste reduction, which is the amount of the incoming substrate that has been reduced during the whole process. So let's say 10, 12 days of larval rearing. On the right side, you see bioconversion rate, which is the amount of biomass, larval biomass produced per kilogram of input substrate, input biowaste. And this data is expressed relative to poultry feed, which is a high performing benchmark. And you can see that cow manure, for example, has a very low performance. The larvae grow on it. They also reduce the waste, but it's not a very high performing substrate in the process in comparison, for example, to vegetable food waste or to mill byproducts, where you have a much higher waste reduction and bioconversion rate that sometimes even exceeds the one from poultry feed. Also, interestingly here, for example, human feces has a fairly high performance. The challenge here is that oftentimes these black soldier fly treatment facilities, similarly also to an anaerobic digester or pyrolysis or any other biowaste treatment technology, is that oftentimes you have different waste coming in, which will mean your larval growth, your waste reduction will be very variable. And this is especially also a concern if you have clients and they're expecting that you're delivering them feed products and you can't deliver because your bioconversion rate is low, because you had a certain substrates coming in that's not really high performing. And one approach here to sort of manage this variability in substrate performance or in rearing performance is to provide substrates to the larvae in similar composition. So here on the left side, you see the protein and carbohydrate content. So carbohydrates is here these NFC, non-fiber carbohydrates of the different waste that I was just talking about. And on the right side, you see formulations where we mix those incoming wastes based on protein and carbohydrate content, so that these different batches sort of had a similar protein and carbohydrate content. And we saw that this increased the bioconversion rate and also reduced the variability of waste reduction, so the process became more reliable. So it's something in general important to consider before starting out such a project or a company, is like, what substrates do I have available in my city? What is the performance of those in the process? In general, substrates that have high amounts of digestible nutrients, such as protein and carbohydrates, have a higher performance than the ones which are high in cellulose and lignin and ash, such as cow manure. So here also, sort of, I'm taking there's sometimes a hype around black soldier fly biowaste treatment. What we often see is that there is a competition between existing resource recovery options. So you see here the waste recovery hierarchy that you probably all know. And for black soldier fly production, products or substrates that are actually animal feeds work the best. So if you have brewery waste, or you have mill byproducts, or you have waste flour from a company, or you have old bread, these are substrates that work very high with black soldier fly larvae. You have a very high bioconversion rate, so your facility will be probably pretty efficient, and you'll produce a lot of quality product. The question is that really a meaningful way of using waste, or shouldn't these substrates be directly used as animal feed according to the waste recovery hierarchy? And if you, for example, don't have animal farms, such as, for example, in Dar es Salaam or in Mombasa, which are mostly Muslim communities, you don't have a long demand for these substrates or biowaste as animal feed. But if you have those, I think it's important to consider that there is not such a strong competition between those. On the other hand, I think that black soldier fly larvae treatment should be considered before energy recovery. So, for example, before anaerobic digestion, according to this sort of amended waste recovery hierarchy. One challenge is that's sort of more of a research topic currently is how can we increase the performance of these very fiber substrates. So here we show sort of banana peels, which are very cellulose, lignin rich, or also I mentioned animal manures. Globally, there's enormous amounts of animal manures produced. How can we increase the performance? And that's where there's a lot of research going on fermentation, pre-fermentation with bacteria and fungi to sort of open up these biowaste for the process. And obviously also one challenge is what are we doing with plastics and paper and glass that's in typically biowaste. So I was mostly now talking about sort of non-domestic biowaste, but obviously most of the waste is locked in domestic biowaste in cities, and this waste is mostly mixed between organic and inorganics. And black soldier fly larvae don't mind plastic; they will just eat around it. But it's obviously a big problem for the process because you have if you have only 50% of organic in your waste, then the larvae will also grow poorly. So now moving on to the product refinement. So once the larvae are fed and grown, there's different products you can produce. And one is that I mentioned is the residue or the frass, which is sort of a compost material that's left behind. Typically that still needs composting. So larval growth is only 2 weeks, 2-3 weeks or less. And the byproduct needs further composting. The other products you can see here on the right, sort of a flow chart. You have fresh larvae, which you can feed directly to animals. You can then dry them and then put them into, for example, a screw press to remove the lipids. So you're basically concentrating the protein in your end product. Fish meal has 65% protein. This is the higher protein content than you have naturally in the larvae, in the dried larvae. So you need this, depending on your product, on your market, you need to remove the lipids further to increase the protein content in your end product. And here also, these are often processes that are existing from other disciplines, from the food industry or from the fish rendering industry. A key challenge, or sort of sometimes the elephant in the room, and also a big research area is feed safety. So differently to composting or to energy recovery options for biowaste, you later using the larvae in the food chain, in the feed chain, but then the animal. So you actually and here that is some of the hazards that are depending on the different substrates. So for example, wastewater sludge oftentimes has high amounts of heavy metals, and these are accumulating in the black soldier fly larvae. But also other waste, such as human feces, has a lot of microbial risks, parasitic eggs, E. coli, salmonella, these typical ones. So it's usually always necessary to have a microbial treatment, so pasteurization, heat treatments. One of the areas that's really unresearched or there's more research needed is misfolded prion proteins. So mad cow disease is always something that comes to mind, but also what about human veterinary drugs that are in animal manures or pesticide residues in vegetable and fruit waste. And this is oftentimes, I think they're in very concentrations, but there's more research needed on what are really the risks there. One way to mitigate is obviously to don't select those substrates or to mix different substrates together so that the concentration in the substrate is very low. Another topic more towards implementation, and this is my last slide, is there are currently sort of two or at least two different business models developing. One is those very large central facilities. So here we're talking about 300 tons of bio-waste coming in per day, and everything is in-house. So the larval offspring are produced in-house, the waste treatment is in-house, the bio-waste, the processing of the larvae into end products is in-house. Versus on the right side, you see more this decentralized approach, which is something that eawag has been piloting in Indonesia for the last years, is that you have a central facility where the more complicated parts of the system are seated, so which is the larva offspring production, so all the flies, you need artificial light, the heating, and also the refinement of the end products. And then more decentralized is the waste treatment. So which means the larvae offspring are delivered decentralized to different waste producers, where the waste is treated, and then the larvae and or the residue is returned to the central facilities. So maybe this is also some stimulation for projects in your cities and your contexts. With this, I would like to close my presentation, acknowledge my funders, which are mostly from ETH and eawag. I encourage you to contact me via email, which is displayed on the top right if you have any more questions. And also I want to list here some more information that you can find both on the ETH website, but also on the eawag website, the followup project, and then these different sort of very practical tools actually that have been developed by eawag to implement black soldier fly bio-waste conversion in cities. With this, I would like to close and hand over to Nele.
Great. Thank you, Moritz, for this very interesting and very good overview about the topic, I think. I mean, it's interesting to see that you see, or that one of the reasons why someone might be interested in black soldier fly larvae is that you, as you said, the valorization, that you get actually like a higher, especially for cities who have to have like a business case for their waste management, right? Like you get a higher or make more money for the output delivered. And also, I mean, also considering that you said that it's especially good for tropical climates, and that also the feedstock needs to be taken into account on which you use. So a lot of interesting things in there. And now we will go to one of those tropical climates to see an example. We're going to Kenya, and Sheila Kibuto is in charge of building and managing relationships with external stakeholders, including the media, to promote Synergy's brand and advance its advocacy work. She has more than 6 years experience in strategic and digital communications, media relations, and advocacy. And Sheila holds a bachelor's degree in communications, public relations. And Sheila will now tell us about the example of Synergy. Unfortunately, you will have to live with her beautiful voice because she doesn't have a camera on her laptop. I hope that doesn't bother you. Sheila, please let me know if, or maybe just let me know if, like, we see your presentation. You can go ahead. Just let me know if we can hear you.
Yes, thanks, Nele. Good morning, good afternoon, everyone. I hope you can hear me.
Yes, very good.
Okay, thank you very much. I'm sorry I can't be on camera today, but I hope you will listen in and learn something and we can engage together. So, yeah, as Nelly said, we are a waste management solution here in Nairobi, Kenya. What we do is we work with cities to be able to clean up cities and make sure that, you know, we are safely managing the waste that is generated. So as you can see from my first slide is that cities are really growing at a very fast rate. We are seeing that every year, currently we have more than half of the population living in cities. And so we're expecting that by 2050, the population in cities will have doubled. Even more to that is that we are seeing slum populations increasing as well. So today we have 1 billion people living in slums, but by 2050 we'll have like 3 billion people living in slums. And so as the population grows, the waste management problem grows as well. So every year we are seeing about 1 billion tons of waste being generated every year, and this is mostly organic and sanitation waste. So when we think about waste, we haven't even talked about the maybe non-recyclables, the plastics and all of that. We are talking about organic and sanitation waste, most of which is still people live with that waste in their cities, and mostly 90% of this waste is not properly treated. Mostly the one that is found in the slums. You find that because people don't have maybe adequate infrastructure, most of them live in their waste. So I'll give you an example of Kenya, where we have a bit of the statistics there. And we see that in Nairobi alone, we usually have about 4,000 tons of waste generated every single day. And half of that waste is usually organic and sanitation waste that finds itself into the environment. Most of it because we are still using a lot of antiquated systems. So we still use a lot of landfills, open landfills and open dumps. So you find that a lot of this waste finds itself in the open dumps, obviously leading to a lot of challenges because we see rising GHG emissions. We're also seeing increased water pollution and a growing health risk as well as a result of this waste. On the flip side, we have another big problem, especially in Kenya, where agricultural yields and soil fertility are declining because of intensity of agriculture. So you find that a lot of our farmers are already importing their fertilizer, most of them still using maybe chemical fertilizers. We are seeing demand of livestock also increasing, and at the same time, the quality of these products is not consistent, and sometimes even the availability is not there. So Sanergy is looking at these two problems and thinking, how can we solve these two problems using what solutions can we build to solve these two problems simultaneously. And so what Sanergy has come up with is what we call a circular economy approach, where we have a closed loop of handling the waste management challenge, and one of it, so it's like a full value chain system where we have a systemic approach to be able to make sure that the waste is removed and it's safely treated, and we make products out of it. So we have a system where we collect all of this waste, we transport it, and then we treat the waste and we repurpose it. And I'm going to discuss each of the steps in detail in the next slides. So every month, we collect about 600 tons of waste through our brand called City Fresh. And we collect two streams of waste. So we collect sanitation waste from urban slums of Kenya, where we have built a network of container-based sanitation units called Fresh Life. And what we do is that we have built a team, as you can see on the right hand side. We have a team that then collects all of this waste and makes sure that it's safely removed from the communities, I know, to avoid the diseases and environmental pollution. And then we also collect kitchen waste, agricultural waste, from pack houses, restaurant waste. We collect all of this waste as well. We have built systems for that. We safely remove all of that waste on a monthly basis, and we get into the way this works is that we have built networks where people have like a monthly subscription fee, where we are able to provide the waste management service to our clients, both in the slums and in cities. So what happens is that once we have safely removed all of that waste, we then transport it. So we have built a system where we track out the waste using trucks, and we have also built a team of engineers who then map out like the roots, and make sure that all of these operations are efficient, especially when you think about the sanitation waste and working in unplanned urban slums. So we have a system where we are able to map out the routes in those informal settlements where the waste will be tracked out easily. And then we also work with the other municipal clients, where we are able to work together to make sure that we are safely segregating the waste, and so that we are able to get the organic waste that we need to bring to the to be able to take out safely from the communities. So once we transport all of that waste, we then bring it to our organics recycling facility, where it is then treated and upcycled into valuable products. So yeah, so the site looks as you can see in the picture, and so the way this happens is that we use what we call the black soldier fly. As Moritz has explained, we rear black soldier flies here in Nairobi, and that is what we use to be able to treat and convert all of this waste. So as you can see from the first step there, we have cages where we rear the black soldier flies. We have quite a number of them. And then, so what happens is that as we rear the black soldier flies, we make sure that we are providing a conducive environment to give them as much a natural habitat as possible for us to be able to have like huge numbers of the black soldier flies. So we take them through the normal they go through the normal life cycle of a fly, but for us, where the waste is mostly converted is at the larva stage. So the larva stage is where we feed the black soldier fly with both a mixture of the fecal waste and the kitchen and organic waste, where we have a team of engineers that then comes up with the recipes, and they build the recipes depending on the stage of the larvae that we are feeding. So for example, if it is a newly hatched larvae, the recipe will be a bit different from like a 5-day-old larvae. So we build those recipes, and then we feed them with all of this organic waste. And once they get to the pre-pupa stage, that is when they are very high in protein content and fat content, and at that point is where we harvest them. So we harvest them at that point and pasteurize them to be able to then produce the insect-based insect-based protein, which we use for animal feed. So as we harvest the black soldier fly larvae, we actually harvest two components. So we harvest both the larvae, and we also get the residue or the frass from the black soldier fly. So the residue that we get from the black soldier fly, we then take it through a thermophilic composting process, where now we are able to manufacture another product, two other products actually. One that is the organic fertilizer, and what we are currently testing now, that is the biomass briquettes. So at every stage of our process, we have a lab that then conducts a lot of testing. As Moritz has said, seeing that we are feeding, we are using waste, it's likely to have harmful pathogens, and so we have both internal testing and external testing to make sure that at every stage we are able to see the kind of products that we are generating. And so at the end of the day, these are the two main products that are currently out in the market. So we have on your right the insect-based protein component for animal feed, and on the right side we have the organic fertilizer. So as you can see, the insect-based animal feed is usually about 30 to 40% crude protein and 40% fat. So this product is one, we are able to provide a quality and consistent product. So you find that initially in Nairobi, feed millers have always used a lot of soya or a small fish that is harvested from Lake Victoria called omena. And this one, so sometimes it does not come in the best of qualities, and it's also seasonal, especially the omena. So you find that we are able to then provide a quality and consistent product from waste that is a lot, and we are also able to, you know, make sure that we are rehabilitating our environment. So as I said, the two products are now certified for sale in Kenya, and the farmers who have been using the product are now seeing a 30% increase in their yields, both from the protein feed and also from the organic fertilizer that we sell. So our site from a distance looks something like that, and we just launched it actually last year, September. We launched this big site, and it's actually like the largest one now in sub-Saharan Africa. So currently we have been processing about 12,000 tons of organic waste, but with this new site starting this year, we are going to start producing about 72,000 metric tons of waste. And so this is waste like from the city municipalities, and we're starting now to partner with a lot of other cities to be able to transfer some of the learnings that, you know, we have seen from trialing and from trialing this BSF waste management project. So out of that, we will be able to then upscale the production of our protein feed to about 3,600 tons, and also produce a lot more organic fertilizer and the biomass briquettes, which is a clean energy. So in Nairobi, we have also, there's also a ban on the use of charcoal because of the cutting down of trees, and so currently being able to provide an alternative clean source of energy that then cleans up, you know, our environment and makes sure that we are reducing the amount of gas in the air. That's a good progress for us. So yeah, so that is our team on the next slide. So those are our leaders. We have the two co-founders, Annie and David, who started the company, and then we have a team of other engineers who then make sure that we are able to build a lot of the technologies that we are using at the factory. And also at the same time, another key thing that we are doing a lot is really working with the government of Kenya and other cities to be able to build the systems that enable us to collect the waste and process it, and even manufacture products that are used by the farmers and are being sold to the farmers. So I'm going to reach there for my presentation. In case you have any questions, I've included one of our teammates' email address that you can use to contact him. Thank you. Thanks, Nelly.
Asante sana, Sheila, for this very interesting presentation. And I've learned, I mean, I've heard a couple of times already, of course, the presentation from Synergy, but I learned today that black soldier fly larvae actually have different recipes for how old they are. So they're just like us. It's very interesting. Thank you for sharing. So now I would like to ask, well, at least Moritz to come back on as well. So I'm not so lonely here with the video while we have Sheila. Maybe we can bring up the agenda in the bottom so we can at least have Sheila's picture again. And now we have still a lot of time for questions and answers. So thank you for the panelists for being really being on time with your presentations. So to our audience, this is now your time to become active, to start asking your questions. You can raise your hands and we will try to unmute you so you can actually directly ask your questions. So there is the possibility for you to raise your hand on your control panel from the go-to setting. So I'm only seeing one hand, and that has been there the whole time, and also there's no microphone to that. So please, while we're waiting for questions from your side, I actually have one and I'll get started to that. Sheila, you said there were different types of, like you showed us in the end that you're planning to have actually 3 different products from your new facility, which you're going to have. Are these 3, just maybe for clarification for all of our audience, are these 3 distinct or like different processes, or are they somehow intertwined, or are they going together for a certain part of the process and then you're branching it out into those different products? Maybe just to give a bit of clarification on that.
Yeah, thanks, Nelly. Yeah, the products are actually intertwined because they all come from the one thing that we do, which is the resource, the waste. So all of these products come from the waste that we collect. So you find that from the black soldier flies, the waste that they generate, which is the frass, is what we further decompose to be able to get the organic fertilizer. And then from the organic fertilizer, the residue that we also get from the sieving is what now we then further compress and make the what we call biomass briquettes for industrial use.
Okay, great, thank you. That sounds very interesting. Okay, I'm seeing we have some audience who has raised their hand. Let me go to first one. Nick, I'm unmuting you. You would also have to, or well, we are unmuting you. Hopefully, you should also unmute yourself and be able to ask your questions directly. You muted yourself again. Nick, please go for your question.
Thank you. Thank you for the presentation. Just a quick question. Have you all, either of you, heard of using water hyacinth as a substrate with BSF? And if so, where was it successful? What are the kind of conversion rates? Thank you.
Moritz, you want to take that? You look very eager. You're now unmuted, sorry.
Now you should hear me. So I know of a study. You shoot me an email, then I can forward you that study. I remember that it was not doing very well. So water hyacinths are green plants, fibrous. I don't expect them to go very well on these sort of substrates. I think if yes, then they would need to be sort of pre-fermented. But I understand where you're coming from. I think there's a lot of water hyacinths around, so harvesting them and feeding them to larvae would be very interesting. But in general, this type of substrate, I think, will not result in very good growth. So I would say bioconversion rate below 5%. So if you have a ton of dry water hyacinths, you will get out less than 50 kilograms of dry larvae.
Thank you. That makes sense, and I'd love to see that study. If I'll email you.
Great, thank you. Then we'll have a question in the chat box or in the box from Sandra. Sandra, you want to ask your question directly? Then you would now have the possibility, if you unmute yourself, we have unmuted you. Otherwise, I will also be happy to read your question.
Yes, thank you very much, Nell. So my question is, like, what are the biggest challenges associated with this type of composting, and whether also a separate question is whether are there any circumstances in any city, for example, that maybe the waste is not the right one in order to partake this kind of composting? Thank you.
Maybe we start with Sheila. Maybe Sheila, you can tell us from your experience what were your challenges, and then afterwards maybe Moritz can add a bit on that from more the research kind of side?
Yeah. So one of the challenges that, so for us, we have done a lot of research for BSF from like 2013. We have been doing a lot of research and still continue to do a lot of research. So there exists not so much literature, especially for practicality's sake. And so one of the challenges that we have constantly had is trying to build a natural habitat as possible for the black soldier fly. We realize that for us to get a lot of yields, we need to be able to provide very good conditions for the black soldier flies to thrive. And so that is why we have taken we have made a lot of investments to be able to create a site that is then able to, you know, to be able to provide those conditions for the black soldier flies to thrive. Then the other one is mostly as regards, you know, just creating systems for it, creating systems for the work, just to be able to, you know, to operate and being able to build partnerships that then make the systems work. One of the things we have really been doing and have really invested on is building very good relations with like government and municipalities, so that we are then able to have operations and build, you know, efficient operations, and also at the same time, at the end of the spectrum, build manufacture products that are then able to that people are able to access. So building those systems and an enabling environment from a policy perspective, those are some of the things that we have really invested in, because they were actually non-existent before we started with the process. So I'd say those are the two main challenges and opportunities that we have really been working on.
Thank you, Sheila. Moritz, you want to add anything on that? Maybe also going again up to the feedstock or whatever, the circumstances where this type of is not recommended?
I think personally the biggest challenge lies outside of the technology. So it's providing or collecting the substrate. So, I mean, now if you're looking at the numbers of Sandec, 600 tons a month, we have, I think in Nairobi, probably 2,000 tons of waste, organic waste produced per day. So it's actually getting source separated substrate at a low price to a resource recovery facility. So that's specific. It's not specific to black soldier fly treatment, but I think that's the big challenge in organic waste management. So I think the technologies are ready. There's, like Sheila said, there's a lot of questions on scaling it, but I think those are technical problems that can be solved. But it's very hard to source organic waste for resource recovery because of lacking affordable collection and source separation.
Thank you. And would you also like to say, Sandra's second question was, are there any circumstances where this type of composting is not recommended? If there's anything you want to add to that?
Yeah, I think like I think I mentioned wastewater. So there could be substrates that are so contaminated. Wastewater has cadmium and lead typically because industries are collected through these systems, and that all ends up in wastewater sludge. And larvae especially accumulate heavy metals. So your larvae will essentially be contaminated and not suitable for a feed market. And to me, this is currently, I think, the only limitation on safety. The other limitation is simply your substrates results in poor growth, which will mean your system will not be worth the effort. So we do not see very big systems working, for example, with cow manure or water hyacinth was mentioned. So if your output is very low per input, it's just not worth the effort. So I would think these are sort of the limitations. And in Europe, for example, all the substrates that are currently allowed to be used as substrate for insects or for black soldier larvae are only certified animal feeds. So the Brachyura larvae are considered as a farmed animal. So there is also just currently in some areas a legal boundary to scaling the technology.
Great, thank you for those insights. Sandra, you have any follow-up question on that?
Yeah,
or
no,
okay?
No, but the only I'm just like, it's very fascinating, this technology to me. So it's kind of new, but one question that I was thinking was, I know that that during the whole life cycle, the advantage of black soldier fly is that you can sell the end product, so you'll have some income out of that. But cost-wise, how does it compare to other type of composting per ton of organic waste? Is it more expensive? Because Shayla just said that you have to have the right conditions to make sure that everything, that the larvae, the flies are in the best conditions possible. So would that require investing more compared to other types of composting?
I think, yeah, from Sandec's experience, it takes a lot more, especially in the research phase. So the investment comes a lot in the research phase just to get it right. But in terms of like the composting and the technology, a lot of our technologies are actually researched and they are in-house. It's I think it would compare relatively the same, only that the research phase is what would maybe differ in terms of like the cost. Yeah.
Okay, thanks.
Okay, thank you. And then we go to the next person who has her the hand raised. Siunda, you want to ask a question?
No,
you're unmuted now. Sorry.
But now, but now I'm following.
Yes.
Hello. Yeah, but this time around I'm able to hear. Otherwise, for the better part of the presentation, I think my computer maybe had a problem. I could not get the voice.
Okay. Do you have any question?
No, not at the moment.
Okay, great. Thank you. Then we go to.
I have liked it.
Then we go to Shiza. You have to unmute yourself. Yeah. There we go.
Okay. Thank you so much for such interesting presentation. So I have two questions actually. First, I wanted to ask about the cost projection about this BSF facilities, if that is to be allocated to municipalities, considering how contaminated their organic waste stream could be if there is no pre-segregation in place. And second, I wanted to ask about from Mertz in particular, if how is the success portfolio looks like from the pilot project that he has been involved in. For instance, I know one BSF facility that was actually done in collab with eawag in. Can you hear me?
Yeah, I mean, I at least lost you for a moment. Maybe it was me. But maybe let's start with your first question and then ask your second question afterwards.
Okay,
who wants to take that one? Sheila or Moritz on the feasibility and also cost effectiveness if there's no source segregation actually? I mean, Moritz already said it's a high challenge, right? But maybe Sheila, you can go a bit about your experience, how you went about that.
Yeah. That's correct. So we have a lot of waste, but then of course sourcing it and getting it at the right levels can be a bit challenging. So what Sanergy has done, so we collect two streams of waste. We collect sanitation waste and we collect organic waste, kitchen waste, agricultural waste from pack houses and all of that. So for the sanitation part of the waste, that has become easy because we've built the systems ourselves. So what we do is that we have built a network of Fresh Life toilets, and these toilets separate the waste at source. So we have the fecal waste that is collected separately from the urine waste, and that reduces the chances of contamination highly, so that then we are able to use, for example, the fecal waste and use it efficiently. So when it comes to the other organic waste, which is the kitchen waste, the market waste, and all of that. So when we work with agricultural pack houses, it's a bit easy because we only get agricultural waste, fruit waste, bananas, and all of that. That's a bit better to work with. When it comes to clients, for example, restaurants, what we are doing is that we have created systems so where we incentivize the clients themselves. So we are able to conduct training where we train them how to source separate the waste, and that way they are able to, the big advantage for them is that they are able to trace and track their waste. So for example, if it is the recyclables, we have built a network of other partners who don't deal with organic waste, for example, the plastics and all of that other waste, where we are then able to dispose this waste to them at a price, and then of course they're able to see the revenues that they get from properly managing their waste. So the value add for them is that also a lot of companies have that component to their operations, where they need to be efficient in how they are managing their waste. And so being able to provide this solution to them, where we are training them how to separate their waste and helping them track the waste that they produce, then this helps them to even be more invested in the process, and that way it makes our work a little bit easier in terms of collecting the kind of waste that we want, and also reducing a lot of the contamination as the waste goes into the processing.
Great, thank you. Shiza, your second question or any follow-up question on this question, or if you want to know anything from Moritz. You should be able to speak. Okay, while you get back in your connection, maybe we go to another question that was posted in the questions box from Daniel. He says, very good presentations. Please, how do you deal with the heavy metals in the residue? So maybe Moritz, if you have any ideas on that.
Well, good question. I think the easiest ones, if you don't have it in the substrate, you don't have it in the residuum. So because some of the heavy metals will go into the larvae, but the bigger amount will stay in the residue. So it is again source control using substrates that are not high in heavy metals. And most substrates in general, like municipal organic solid waste typically is not very high in heavy metals. So I would say the easiest way is source control. Getting heavy metals out of the residue, to my knowledge, there's no economic solution there. Probably here people would dilute it with other compost, but the best way is to have source control with this from the substrate.
Great, thank you. Sheila, did you have any issues with heavy metals in your operation so far?
Not quite, because as I said, we have very controlled waste. Especially a lot of the heavy metals will come also when you're dealing with grey water, and especially when it comes to like the sanitation waste. And so what we do is that for us, the Fresh Life toilets separate the waste at source. So we very much are able to control the waste that we collect and we process. So we are able to really minimize a lot on the heavy metals in our process. So they don't get to the feeding of the larvae, which means then we don't get a lot residue that has a lot of that.
Okay, great, thank you. Then Maybe going back to Shiza for her second question.
Yeah, sorry, I lost my connection there. Yeah, so I wanted to ask my second question about the success portfolio of the pilot projects that maybe Moisha Shalabot could have been involved in. For instance, here in Pakistan, we had one pilot project in collaboration with eawag actually in Lahore in 2016, but I don't know the reasons for its shutdown, but they could no longer run it out. So just wanted to know from the experiences how from the other pilot projects across the geography or if any. Yeah.
Moritz, you feel like you can answer that?
Yeah, I mean, I share your view. Also, there's a lot more pilots than successful large-scale facilities. I don't know specifically what happened in Lahore, but there are several reasons. It could be lack of capital for scaling. So typically going from a pilot to a big facility, that's also the case for Sandec, needs a lot of money in the millions. So it could be that its capital was not available. It could be that substrate was not available. The market for the end product was not available. Investors saw too much risk in the business. So I think there can be many reasons why such pilots don't scale. And I think that's not untypical for other technologies too, that we're in this phase where we're still learning a lot about the technologies, a lot of R&Ds, like also Sheila said. So I'm not worried that these pilots sort of, some of these pilots fail. I think it's more important that we see these big projects or these big facilities working.
So I'm just seeing that Christian Surbrück, who is working at eawag, as well, he mentioned that Pakistan was just a research project, a PhD thesis, so that's probably the reason why it didn't scale up. But Moritz, do you know of any, or like, can you give some positive examples of pilots that were maybe in the end successfully scaled up? Do you have any examples? Just maybe to shortly mention for Shiza.
Well, I think the followup project in Indonesia from eawag is a good example. It started out as a research project. So it's in Surabaya, a big city in Java, in Indonesia, and it started out as a research project, and it sort of over the years led to sort of replication of the technology, not only in Surabaya but also in cities on Java, on Bali, on Lombok, so within Indonesia. So, and why did that happen in Indonesia and not in Lahore? There's probably a lot of reasons, but for example, one was also the climate in Indonesia is very suitable. So there are examples where these research or pilot projects are sort of taken up and result in replication and sort of larger upscaling.
Great, thank you for sharing. And Sheila, I have another question for you from the audience who someone was too shy to raise the hand and just posted it in the question box again. Jack wants to know, how do you make sure the substrate is clean and does not support the growth of contamination or maggots?
So what happens is, so as I mentioned, right from the source, we are able to make sure that we track our waste from the source, so that then we know what kind of waste we are bringing into the site. And then the other thing is that black soldier flies are really, ferocious feeders. Like, they feed a lot. So in fact, we actually don't have, sometimes we run out of the feed stock itself. So once we have gotten the feed stock, most of them feed within like a day or two. So they're able to feed on like fresh feed stock that is well balanced and of course well tested. As I said, we also have a lab where we are able to really look at the substrates that we are providing, and also just testing, of course, how the substrate is doing. As Moritz has said, some of the food may not yield in high results, and so what we do is that we make sure that we are feeding the black soldier flies what they would actually consume and give us high results. So I would say those are some of the ways in which we make sure that we are able to provide to make sure that we have quality feedstock going in and also quality products coming out.
Great, thank you very much for sharing. At this point, I would like to use the opportunity to ask our audience another question and to launch our third and last poll before everyone goes away. So please, here it is. Everyone, feel free to get an action and use your mouse or whatever to, do you think black soldier fly composting could be an option in your city as well? Please select yes, no, not sure, you would need more knowledge about it. So we're giving you some more time because we want to get a lot of you to answer that, to give also feedback maybe to our panelists to see this. And just a few more seconds for you to decide your mind. And then we can close the poll and we will share the results with you. And as you see, actually, no one said no. So everyone is very, well, more or less convinced. 2/3 say it could be an option in their city, and 1/3 said not sure and they would need more knowledge. Thank you to the audience for sharing that. And I think it's time, unless I'm seeing one last question or someone raising their hand. Let me have another look. Otherwise, I would very much thank both our, let me just check if there are any other hands raised. I don't see any. Okay, great. So Sheila and Moritz, very warm thank you to both of you for taking your time and presenting to us and also taking the questions and also for providing your email addresses for further questions. And thank you for the audience for joining today. We will, as I said, we will post the recording and the slides, some in the coming days, maybe next week, on the NUA Campus website. We will also share them, let you know for everyone who joined once we have done this. And we will hopefully see you soon, maybe next month. We haven't planned yet the next part of our deep dive waste management technology deep dive series, but we will probably look at material recovery facilities. So going away from the organic waste and looking at some, or maybe not only, but also adding up some other components, or just looking at a different part of the system. So happy to see you then. Stay tuned for more of our series, and wishing you all a good rest of the day. Thank you so much.